In this lecture, we're going to talk about vector fields, which model a few important physical phenomena. Let me start with my favorite example. Let's imagine you have two celestial bodies. It could be, say, like the Earth and the Moon, or two planets. And now imagine you have an object here in space, and you're looking at the force of gravity on that object. Well, we know that the force of gravity is going to be the sum of the forces from the gravitational attraction of all the objects. So in this case, I'm going to have some attraction in this direction, some smaller attraction in this direction, and so the resultant force is something like that. And at all these different points, if I look at the resultant force, like if I have a point very close to this planet on the right here, and the vector is mostly going to point toward the center of that planet. If it's close to this one here, it's going to point mostly to its center. But then, for example, say on the line in between them, well, somewhere there's going to be a point where the force is 0. And so you just end up with all these different force vectors that depend on where you are. So the input then is, say, in this case, your x-coordinate and y-coordinate, and then your output is a vector. And we're going to use some sort of standard notation here. We'll call the first component P and the second component Q. And so P and Q are just ordinary functions of x and y. So this is the force at the point xy. Okay, so that's one very common use of vector fields. A vector field then is essentially a function of this type that takes 2 or 3 variables as input and then spits out a 2 or 3-dimensional vector. Of course, in principle, really, this ought to be sort of a 3-dimensional vector field, right? If we're talking about sort of gravitation in space, you have 3 dimensions. And so then the output will be some function P of x, y, z, some function Q of x, y, z, and then some function R of x, y, z. And often we'll just write that as P, Q, R, and understand that those are all functions of 3 variables. Okay, another important physical phenomenon that is modeled by vector fields is fluid flow. Right, the flow of water or air, where again, when you have, say, water flowing in a river, well, maybe for a while all the water is sort of flowing in the same direction, but if there's a big rock somewhere here in the middle, then that's going to divert the flow some. And so you end up with these different flow vectors depending on where you are in the flow. And so again, you have some function f where the input is a position, it's where you are, either 2 or 3-dimensionally, and where the output is some 2 functions that determine the components of your vector. Okay, so in general, these are all what we call vector fields. So a vector field is a function, capital F of x, y, or x, y, z, P, Q, R, where P, Q, and R are the same as they were over here with the force. Okay, so what we want to do is try to understand vector fields, and I'm going to start by trying to sketch a couple of simple 2-dimensional examples. So let's try to sketch the vector field f of x, y is equal to 1, x. Now, how are we supposed to sketch something like this? Well, we're going to use either fluid flow or force as kind of our metaphors. Maybe fluid flow is a little bit more concrete to think about. So we're going to think of f as telling you what direction the surrounding fluid is going in at each point. And so what we might do is start by, say, over here, I'll sketch some axes, and we'll mark out a couple of points here on the x and y axes. And so then what we might do is make a table of some points and then the corresponding vectors that you get. So for example, if I plug in the say the point -2, 0, well, the output, the x component of the output is always 1, and the y component, the vertical component, is equal to the x coordinate. So it's this vector -1, 1, -2. And so the idea would be that starting at -2, 0, we would draw a vector that looks like 1, -2, or at the very least a vector that is parallel to that. And I'll draw that in a second. Let me go ahead and calculate a few more of these. So at -1, 0, you get the vector 1, -1. At the origin, you get 1, 0. At 1, 0, you get 1, 1. And then at 2, 0, you get 2, 1. So that gets you the vectors all along the x-axis here. And so what happens is that the picture gets really messy if you actually draw all of these vectors to scale. So we're going to kind of scale everything down, by some kind of arbitrary amount here. So this vector 1, -2, well, I'm just going to draw a vector that goes over some amount and then goes down twice that amount, right? Any vector that's kind of in that direction sort of communicates the same thing. And so we're going to anchor that vector at the point -2, 0, which is right here. I don't know how great of a job I did there, but that's fine. Here's the vector 1, -1. So again, that's going to go over 1 and down 1. So it should point from this point sort of in the direction of this one down here, but not the full length. At the origin, we get just a horizontal vector. Here we get one that's going up and to the right. And then we get one that's going, oops, I messed that up actually, sorry. That should be 1, 2. So that one goes over 1 and up 2. So it goes more up than over. Okay, well, as you can see, this is a little bit time intensive. There are some things in this case that are going to help us. Let me maybe point out that if you look at, say, -2, 1, or -2, 2, or -2, -1, I mean, those all have different y coordinates, but our vector field doesn't depend on y, in fact. All of those points have the same vector, 1, -2. And so, in fact, in this case, what happens is that as you move up and down, the flow vectors all stay the same. So I'm going to have a vector here, and here, and here, and here. All of these vectors in this first column are parallel to one another. Same thing in the second column. Same thing in this column here. And then this one. And then this one. Okay, well, I mean, that turns out to be kind of a lot of work. In this case, we were lucky that there was no dependence on y, so that once I had done one row, I could kind of just fill in the columns. But in general, it's really hard to get a sense of a vector field just by sketching it by hand. So next time, we're going to see how you can use some online tools to sketch some good graphs of vector fields.